Hi dear students, welcome you all to Prelim Group of Institution. Here we are going to discuss how to do the salt analysis in a chemistry lab. Dear all, a given salt contains cation and anion. So we have to report to the teacher the given salt contains this as the cation and this as the anion. So here I am going to discuss certain cations and anions, how to do the preliminary test and confirmatory test, what is observation and all we can discuss in detail. Dear all, welcome you once again to the Prelim Group of Institution. The given anions, let me discuss the anions here. They are maybe carbonate, chlorides, sulfate, nitrate and acetate. These are the anions we are going to discuss today. And cations, cations are grouped into around 0 group, first, second, third, fourth, fifth and sixth groups. 0 group contain ammonium. So we are discussing certain cations today. 0 group, ammonium. We will discuss about ammonium, the preliminary test and confirmatory test. And lead. Then we have aluminium. Then barium, calcium, strontium and magnesium. These are the cations and anions we are going to do in the salt analysis today. There are different kind of salts can be provided. You can able to see that these are colored salt, right? These are colored salts. And there is a colorless salt. The colored salt, for example, blue color, you can able to see that this salt is in blue in color, which indicate that it may be a copper salt. It can contain Cu2 plus copper salt. Copper salts are generally blue in color. Another one is a pale green color. You can able to see pale green color. Pale green color indicate that presence of, maybe it's a ferrous salt. What is ferrous? Fe2 plus, right? Ferrous salt. And it's having a brownish color. The brownish color indicate that it may contain ferric. What is ferric? Fe3 plus, right? Fe3 plus ferric. And dear all, mostly they will give you colorless salt for your examination. Colorless salt, if they given, we can say that the absence of copper, ferrous and ferric. These kind of salts, this kind of colored salts are absent. So mostly for your examination, they will provide here all colorless salt. After identifying the color of the salt, as I told you, there is two different color salt you can give it. Some is colored salt, some one are colorless. But most of the examination, they will provide colorless salt, which indicate the absence of copper, ferrous and ferric, right? So dear all, here we are going to analyze what is the order of the given salt. So they will give you a colorless salt. And what is the order? What is the smell of the compound? So don't try to, whenever you're getting, if you're trying to get the smell of the compound, don't try to smell directly. There are maybe some nicogens, nitrogen compounds are very suffocating compound. They form very strong irritating smell. So whenever you trying to get the order of the compound, try to get a wave. Try to get the wave and you will get the smell. Okay, by using the wave, try to get the smell. So what is the order? There are two salts which is having some particular smell. That is, if the smell is like a vinegar smell. If it having a vinegar smell, you can able to say it may contain acetate ion. Acetate ion. What is acetate ion? CH3COO minus as anion. One another is a pungent, a strong smell. That is what? Ammonia. A ammonia smell, a strong smell if you're getting, you can able to say that maybe the compound contain ammonium as cation. What is ammonium? NH4 plus. So vinegar smell, acetate ion, pungent, strong smell, that's ammonia smell which indicate ammonium as a cation. Let's do the flame test analysis. Flame test is a very interesting one. So let me take a watch glass. To this watch glass, let me add a pinch of the given salt. A pinch of the given salt, let me add. Now we have to make a paste of this given salt with a concentrated HCl. So concentrated HCl. By using a dropper, let me add a very few drops of around 1, 2, 3 drops of concentrated HCl. Okay, let us add. Now we can rub this one, mix the given salt, the concentrated HCl, mix very well, okay, mix very well and make it as a paste. Make it as a paste. Then let me just on the flame Okay, carefully listen all of you. See the color change of the flame, okay? What is the color you can observe? Very carefully try to observe. You can able to see that there is a brick red color is generated. Brick red color, right? This brick red color indicate that it may contain calcium as a cation. Once again, I am showing that. There is a brick color generated, right, which indicate it may contain calcium as a cation. This is the flame test for calcium. Let's see the next one. You can able to see that it's a bluish green in color. The bluish green color which indicate that it may contain copper as a cation. Carefully observe all of you. It's a bluish green in color. Let's see what is the color of barium. You're all barium that will glow with. You can able to see that a pale green color, pale or apple green color. That's a flame which indicate barium. Let's see the next color. This is the crimson red color. If it burn with a crimson red color, which indicates strontium may be present. There is another color, brick red we studied, crimson red color with it. That's entirely different, right? So this is the brick red color, which indicates strontium may present. Let's do another preliminary test, that is ash test. Already flame test we observed. Now we are going for the ash test. That is mainly to confirm the presence of aluminium and zinc. Carefully listen, it's a very interesting procedure. Let me take a pinch of salt into the test tube. Okay, pinch of salt. You can do this ash test either with the given salt or salt solution, to which let me add concentrated nitric acid. Okay, I'm going to add it. For the ash test we are using concentrated nitric acid. So let me add some amount of concentrated nitric acid into the solution. So the nitric acid, after adding few drops of nitric acid solution, let me add some amount of cobalt nitrate. So what are the main thing in ash test? Concentrated nitric acid and cobalt nitrate. This is the cobalt nitrate solution. Then let's add a few drops of cobalt nitrate solution also. Okay, everything we added. Right. Now dear all, we are going to heat this solution. Alright. Now we can heat this solution by using a non-luminous flame. Okay. After heating, take a strip of a filter paper, okay, a piece of filter paper, and dip in the solution. Dip in the solution, make it wet. Dip in the solution and make it wet. Alright. Now it burn into ash. Burn into ash. Here we are not checking the flame color, we are checking the ash color. Okay. Now we can able to see there is a ash generated. Dear all, let me show you what is the color of this ash. Now you can able to see that this ash color is green in color, which indicate the presence of zinc, Zn2 plus cation. Now you can able to see that the ash color, you can able to notice that it's a blue in color, which indicate presence of aluminium cation, Al3 plus. Let's start with anion analysis. So first I am going to do the preliminary and confirmatory test for carbonate anion. So first I am going for the preliminary test of carbonate. I am taking a test tube. Alright, we have a test tube. And you're all, please don't hold the test tube like this. You know, the reactions are happening the bottom part, so you have to see that. So hold the test tube like this. Alright, 2 fingers are enough. Right. So this is a test tube, to which I'm going to add the given salt. A colorless salt is there, right? They will provide a colorless salt. So to which I'm going to add a pinch of salt, very small amount of salt with a spatula. All right? Okay, salt is there. If you're doing carbonate test, you can do the experiment either with the given salt directly or you can make it as a solution. Alright, so to which this salt I'm going to add dilute hydrochloric acid. Dilute hydrochloric acid we are going to add into this test tube. Alright, what is the test? Before doing the experiment, we have a clear idea what is the observation. So what is the observation to this given salt when you add dilute hydrochloric acid? They are all brisk effervescence. What is meant by brisk effervescence? Bubbles. What that bubbles? Carbon dioxide reaction. Carbon dioxide are produced. Let's see, and very carefully dear all, at the moment when you adding the dilute HCl, at the same instant you have to observe it whether there is a bubble generation or not. Okay, so I'm going to add dilute hydrochloric acid to this test tube. So carefully listen all of you, what is the observation? Alright, see the bottom part of the test tube. You can able to see bubbles are generated. Can you able to see that? There is brisk effervescence, some bubbles are generating, right? So if this brisk effervescence generated, you can say that the given salt may contain carbonate. Now we can do the confirmatory test for carbonate ion. Now we saw that the given salt may contain carbonate ion because of the brisk effervescence generation. Now we have to confirm that the given salt contain carbonate as anion or not. After the confirmatory test only we have to fix about our answer. Okay, so I'm going to take a test tube again, to which I'm going to add a pinch of salt. Again I'm repeating, always when you're doing the experiment add a pinch of salt in this one. Okay, pinch of salt is there, that's I already added. To which I am going to add barium chloride solution, BaCl2, barium chloride. Before that, you have to make the solution of this one. The previous experiment we did with a salt or salt solution, we can do it. Here I am going to do the experiment with a salt solution. So add some amount of water and shake it well and dissolve it. Okay, maximum shake it and dissolve it. So this is a salt solution. Okay. To the salt solution, we have to add, they are all barium chloride. This is the barium chloride solution. It will be available in your lab. So barium chloride solution, we have to add into this one. See what is the observation. They are all, I'm going to add barium chloride solution to this one. You can able to see that a white precipitate formed, right? A white precipitate formed. And this is not the confirmatory test. We have to do something. So to the salt solution, we add barium chloride and white precipitate form. To this white precipitate is soluble in dilute HCl. So let me add, again I am taking dilute HCl to this solution. Let me add, either you can take a small portion of this salt is enough, because if you want to dilute this one, more amount of HCl may require. So take a small portion of this solution. Okay, so I am taking a small portion of this solution. Okay, a small portion of the solution to which I am adding dilute HCl. So dilute HCl, when you adding to this one, dear all, you can able to see that white colored precipitate is soluble. Now it's a clear solution. Can you able to see that? Now it is a clear solution. If you get like this, you can confirm that the given salt contain carbonate as anion. So after the confirmatory test for carbonate ion, we are going for the acetate ion preliminary test and confirmatory test. So what is the preliminary test of acetate ion? Acetate, CH3COO minus anion. For that, I am taking a watch glass, to which I am adding a pinch of salt. Okay, pinch of salt into the watch glass. Then add a few drops of concentrated H2SO4. I am taking concentrated H2SO4 by using a dropper. Let me add 2-3 drops into the watch glass. Okay, concentrated H2SO4, 2-3 drops let me add. Then dear all, rub this concentrated H2SO4 with the salt with a glass rod. Okay, with a glass rod, rub it well. And we have to just get the odor of this salt solution. So when you're trying to get the odor of the solution, please don't try to smell like a direct way. Try to get the odor through a wave. Smell it. we'll get a acetate smell. You know, vinegar smell. If you're getting a vinegar smell, then you can say that the given salt may contain acetate as anion. But if you want to ensure that it's an acetate ion, we have to do the confirmatory test. So what is this test here all? To a little of salt, add 2-3 drops of concentrated H2SO4, rub it with a glass rod and try to get the odor. If you're getting a vinegar smell, which indicate that it may contain acetate as anion. Now let's go for the confirmatory test. Take a pinch of salt into a test tube. A pinch of salt into the test tube and make it a solution by adding some water. Okay, add some water and make it as a solution. Maximum try to dissolve it. Then add neutral ferric chloride solution. Neutral ferric chloride solution, we have to add it. What is observation? You can get a reddish brown precipitate. Okay, see very carefully, a reddish brown precipitate. You'll get a reddish brown precipitate which confirm the presence of acetate ion. Let's go to the preliminary and confirmatory test for chloride ion, Cl-. First of all, the preliminary test. So take a pinch of salt into a test tube. Okay. To the salt, we can add concentrated H2SO4. Okay. Few drops of concentrated H2SO4, we can add it. Concentrated H2SO4, let's add. We can able to see that, just to wait for few seconds here all, there is a colorless gas generated. It's a white color, a colorless. The colorless gas become denser. Take a glass rod and dip in ammonium hydroxide. Dip in ammonium hydroxide solution and show the tip of that one on the, you can able to see that on the mouth of the test tube. When you show it, you can able to see that a dense white colored fumes are generated, right? Very dense white colored fumes are generated, which indicate the presence of chloride ion. Let's go to the confirmatory test of chloride ion. Take a test tube, add a pinch of salt into the test tube and make it a solution. Okay, salt solution. So let me add some amount of water. Okay, mix it well. So to the salt, we added some amount of water. Make it a salt solution first. To which first you add dilute nitric acid. So dilute nitric acid. Am I going to add dilute nitric acid? Small amount of dilute nitric acid. Okay. Then add silver nitrate solution. Few drops of silver nitrate solution. We can able to see that a white curdy precipitate. A white curdy precipitate is forming. Okay, white curdy precipitate is forming. You can able to see that. Now, this is this white curdy precipitate which is soluble in ammonium hydroxide solution. So let me take ammonium hydroxide solution. Okay, already what all things we added here all? To the salt solution we added dilute nitric acid, to which we added silver nitrate. We got a white curdy precipitate which is soluble in ammonium hydroxide. So let me take ammonium hydroxide. So if you add more amount of ammonium hydroxide to the entire solution, which may not dissolve, so add a little amount of this one. Okay, so let me take only a small amount of this portion. Okay, very small amount of this portion, to which let me add ammonium hydroxide. See all of you, when you adding ammonium hydroxide to this one, that white curdy precipitate is almost going to dissolve. Let's do the preliminary test for nitrate ion. That is a reddish brown gas generation. Test is there. So take a pinch of salt. A pinch of salt into the test tube. Okay. To which let me add concentrated H2SO4. Okay. A few drops of concentrated H2SO4 is adding. Then we have to heat the test tube. Okay. So what all things? The salt with the concentrated H2SO4. Then heat the test tube. Before that, you should be ready with a small piece of paper. Okay. This paper, make it as a ball. This is called a paper ball test. A small piece of paper, make it as a ball. Just keep it there. First, let me heat the solution. So only salt and concentrated H2SO4 is there. Okay, just to heat it and add this small piece of paper into the solution. You can able to see that a reddish brown fumes, right? Reddish brown gas is generated. Let's go to the confirmatory test for nitrate ion. Dear all, nitrate ion, that's a confirmatory test is called brown ring test. It's a very difficult to get it, but easy. But don't shake the test tube while you're adding the reagents. Okay. So let me take a pinch of salt. Let me take a pinch of salt into the test tube. Okay. Pinch of salt into the test tube. And make it as a solution. You can add some amount of water. Few drops of water we can add it. To which let me add freshly prepared ferrous sulfate. It's a ferrous sulfate solution, a pale green colored solution. Freshly prepared ferrous sulfate solution, we have to add it. Okay. Now, don't shake the test tube, dear all. Don't shake the test tube. Without shaking the test tube, you have to add concentrated H2SO4. Concentrated H2SO4 through the side of the test tube. So, how to add it very carefully. So, dear all, this is the solution. And just hold the test tube like this with a 45 degree, almost like this. Then add concentrated H2SO4 to the side of the test tube, drop by drop. Without shaking the test tube, you have to add concentrated H2SO4 through the side of the test tube. Okay. Slowly, we have to, without shaking the test tube, add concentrated H2SO4 through the test tube. Now just hold the test tube like this one. You can able to see that there is a brown ring. There is a brown ring form in the middle of or the junction of the two liquids. Let's go for the test for sulfate anion, SO4 2-. First, let's go for the preliminary test. Take a little of salt and add some amount of water. Make it as a solution. Okay. So, to a little of salt solution, add barium chloride solution, BaCl2. So, let me take barium chloride solution. They're all a white precipitate formed. You can able to see a white precipitate form, right? A white precipitate. And the observation, this white precipitate is insoluble when you add dilute HCl. So let me take dilute HCl. Let me add it. It should not dissolve. Okay, the white precipitate should not dissolve when you add dilute HCl. See, the white precipitate still remains. So what all things? To the salt solution we add barium chloride. So to which first it form a white precipitate which is insoluble in dilute HCl, which indicate presence of sulfate. Let's go for the confirmatory test for sulfate ion, SO4 2-. So to a little of salt solution. So let me take a pinch of salt and make it as a solution by adding few amount of water. Okay. So to a little of salt solution add lead acetate solution. Okay, lead acetate solution. Lead acetate solution. Yes, we can able to see that white precipitate form. White precipitate form, which means it indicate that presence of sulfate as anion. Let's go for the confirmatory test for sulfate ion, SO4 2-. So to a little of salt solution, so let me take a pinch of salt and make it as a solution by adding few amount of water. Okay, so 2 little of salt solution, add lead acetate solution. Okay, lead acetate solution. Lead acetate solution. Yes, we can able to see that white precipitate form. White precipitate form, which means it indicate that presence of sulfate as anion.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.